atoms. Have you ever heard about Maharishi Kannad? Maharishi Kannad was an Indian philosopher. He had said that on breaking again and again a matter, we get the smallest particle. Later on, a scientist, Antoine Laurent Lavoisier, had proposed two laws. One was the law of conservation of mass, and the other, the law of constant proportions. British chemist John Deltan had given the basic theory related to the nature of matter. He had taken the name atoms as given by the Greeks. He had proposed that atoms are the smallest particles of matter. According to Deltan's atomic theory, it was believed that all matter is composed of small particles called atoms. Atom is the smallest particle of matter. This is a postulate of Deltan's atomic theory. Let's try to understand it with the help of an example. Let's take a stone and try to break it into small pieces. Each small piece of the stone represents an atom here. According to Deltan's atomic theory, as we know, atoms can neither be created nor be destroyed. Let's see what does it mean. Let's take a look at coal. Oxygen molecules are present in our atmosphere in gaseous form. We all are aware with this thing that coal is made up of carbon atoms. When coal is heated, carbon atom present in it goes into gaseous form. These carbon atoms combine with oxygen in atmosphere to form atmospheric carbon dioxide. Postulates of this theory may be stated as follows. All matter is made of very tiny, indivisible particles. These tiny particles are known as atoms. Atoms are indivisible and indestructible. Atoms can neither be created nor destroyed in a chemical reaction. Atoms cannot be changed into atoms of other elements. All atoms of the same element are identical. Atoms of a given element are identical both in mass and properties. Different elements have different types of atoms. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. The relative number and kinds of atoms are constant in a given compound. Atoms of same elements can combine in more than one ratio to form more than one compound. Compounds are formed from atoms of the constituent elements. Atoms are the smallest unit of an element. Atom maintains chemical identity throughout all chemical and physical changes. Chemical reactions occur when atoms are rearranged. In this way, we can say that Deltan's atomic theory suggests that the atom was indivisible and unbreakable. Let's discuss postulate of Deltan's atomic theory. Atoms of the same element are alike. Let's take an example to clear this postulate. Let's have a look on charcoal and diamond here. What is present inside charcoal and diamond? Let's see. As we know that charcoal and diamond are made up of carbon atoms, is there any similarity in carbon atom present in charcoal and diamond? Carbon atoms present in charcoal and diamond are alike or not? Let's discuss it. If we see carbon atoms at micro level, we find that carbon atoms neither present in charcoal or in diamond are of the same size. It proves that atoms of the same element are always alike. The most significant concept that Deltans' atomic theory had proposed was of the atomic mass. According to Deltans' atomic theory, each element had a characteristic atomic mass. Deltans' atomic theory was based on the laws of chemical combination. His theory also gives an explanation for the law of conservation of mass. His theory also explains the law of definite proportions. His theory also proves that each element had a unique atomic mass. If we compare the masses of carbon atoms present in charcoal and diamond with the help of beam balance, we find that in both cases, carbon atoms have same atomic masses. We see that beam is balanced. If we compare the masses of carbon atoms present in charcoal and iron atoms present in an iron piece with the help of beam balance, we find both atoms have different atomic masses. In this case, we see that beam is not balanced. Discovery of subatomic particles inside the atom led to the failure of this aspect of Deltans' atomic theory. These two fundamental particles were electrons and protons in an atom. Atom is divisible. Isotopes have slightly different masses. Today we know that atoms can be destroyed with the help of nuclear reactions. We also know that there are different kinds of atoms within an element that are known as isotopes. Isotopes of an element have the same chemical properties. According to Deltans' atomic theory, as we know, atoms of different elements differ. Let's have a look on postulate. Let's compare atoms of two different matters. As we know, charcoal is made up of carbon atoms and iron piece is made up of iron atoms. If we look at carbon and iron atoms at micro level, we find that both differ in size. When scientists started exploring matter, they realized that matter can be divided into smaller and still smaller particles. They discovered that the smallest particle of an element that maintains its chemical identity through all chemical and physical changes is called an atom. Atom was derived from the Greek word atoms, meaning indivisible. Thus, it was considered to be indivisible. Let us now discuss about the nature of atom. Atoms are made up of protons, electrons, and neutrons. Protons are positively charged particles. Electrons are negatively charged particles, and neutrons are neutral. Protons and neutrons are found in the nucleus of the atoms, while the electrons are found on the shells. Matter is anything occupying space and having mass. It is the material of the universe. Atom as a whole is electrically neutral. As you see in the animation, a carbon atom is shown. In the center, you find a nucleus consisting of protons and neutrons. Surrounding it are two orbits, where we find electrons. Protons are shown in green, whereas neutrons are shown in red. The atom, on whole, is electrically neutral. Is the smallest particle of an element, which can take part in a chemical reaction. It retains its chemical identity throughout all chemical and physical changes. The relative sizes of some extremely small matter are as in the table. An atom is the building block of all matter, the smallest particle of an element. More than 115 types of elements are known around us. An atom can exist in ground as well as in combined state. Noble gases exist in free state. Atoms can be seen with the help of scanning tunneling microscope. Symbol of elements. A symbol is a shorthand notation used to express an element. Deltan used to represent one atom of an element. Some of the symbols used by Deltan are as shown on the screen. There was confusion regarding the names of the elements. Initially, the names of the elements were derived from the place of their origin. Some names were given to the elements on the basis of their colors. The name gold was given because it means yellow in English. Berzelius suggested that symbols of elements should be taken from one or two letters of the name of the element. International Union of Pure and Applied Chemistry (IUPAC) nomenclature is used these days, which has guidelines for naming elements and assigning symbols. The symbol of an element consists of the first letter or the first letter and any one or other letter in its name in English. The first letter must be capitalized and the second should be in lower case. Element, symbol. Boron, B. Aluminium, Al, and not Al. Symbols of some elements are formed from the first letter of the name and any letter appearing later in the name. Element, symbol. Chlorine, Cl and not Ch. Zinc, Zn and not Zi. Let us have a look at symbols of elements represented by only first letter of the English name of the element. English name of the element. Symbols. English name of the element. Symbols. Hydrogen, H. Oxygen, O. Boron, B. Nitrogen, N. Carbon, C. Phosphorus, P. Fluorine, F. Sulfur, S. Symbols of the elements represented by the first letter and any other letter of their Latin or German names. English name of the element. Latin or German name. Symbols. Silver, argentum, Ag. Copper, cuprum, Cu. Gold, aurum, Au. Iron, ferrum, Fe. Sodium, natrium, Na. The atomic mass standard is based on an atom of the isotope of carbon-12. Standard atom of carbon, C12, can be represented as carbon-12, 6. Mass of one carbon-12 atom is equal to 12U. When this carbon is cut into 12 equal pieces, mass of one piece of C12 carbon atom is equal to 1 by 12 times mass of one carbon-12 atom. This is further equal to 1 by 12 times 12U, which is equal to 1U. This means that relative atomic mass of an atom is equal to mass of an atom divided by 1/12 mass of a carbon-12 atom. This means that an atomic mass is the average relative mass of an element's naturally occurring atoms on a scale that uses atoms of carbon-12 as reference. Let us have a look at relative atomic masses of some elements. Element, atomic mass, U. Hydrogen, 1. Carbon, 12. Oxygen, 16. Nitrogen, 14. Magnesium, 24. Sodium, 23.